A few things. If you have questions at any time, just raise your hand. I'll try to get you. So we'll have questions while the lecture's going. Don't just wait till the end, because we're going to be covering a lot of topics. I'm going to be moving pretty fast. I tried to put enough information for people who are advanced to be interested, and people who are like sophomores, freshmen, to not be lost. I want this to be for everyone, but of course that's very difficult to do. So questions will hopefully solve anything I missed. Oh, let's go here. So who am I? Trip Connell. I was the tech director on Paint Party Panic, and Nouse, and other stuff, but architect enthusiast, I guess. I've been doing it for a long time, and it is something I think about all the time when I'm sleeping, when I'm not sleeping. I have dreams about it. They're very horrifying dreams, very bad. And so I'm about to graduate. Well, it really doesn't want to go to the next slide. I'm about to graduate, so I thought I would just dump everything I've learned onto a presentation, and here it is. So why architect? There's a problem now in the industry. It's not really a problem, but it's a problem if you want to be an architect. There's a lot of engines out there, and not many people are hiring architects to make grand engines. So why do we do at DigiPen if we can't get a job necessarily in that area? Architectural thought is a generally useful skill. It'll apply to any API design you're doing, anything you're doing, really. Any function you write, function signature design, any code you write. This kind of thought process will help you write better code, more legible code, more efficient code, easier to use code. Then you can also understand decisions behind other engines. When I look at Unity, I can see, oh, I know why they did that. I know why they did that. It makes it easier to use and easier to understand because I understand the decisions they made. And it helps you learn to write code that will be used by others. If you're writing an engine, you're writing code that will be used by everybody else on your team. They will have problems with it, and you'll learn how to write code that will then be used by other people. My job is going to be in DirectX. I got that job because I knew my code would be used by almost everybody who writes a game out there, which is what I wanted. And they were very happy at my interview to hear that that was something I was interested in. So this is a slide where I dump wisdom on you. Hopefully it's all true wisdom, and then I'll be going into more details, but this is just kind of broad knowledge. So you want to prefer simplicity to complexity. If there's a complex answer and a simple one, prefer the simple one. The complex one might be right, but you should go to the simple one first, and then consider the complex one, but prefer the simple one. Program to help others. When you're programming an engine, don't really be thinking about yourself, thinking about your teammates. What do they need? What do they want? What does your designer need? Try to help them. If you see that they're unhappy, you should feel sad, and you should help them. Be very empathetic. It makes a good programmer, makes a good architect. Observe how your code is being used. If your teammates are having repeated problems with something, that's probably your fault. You can blame them, but it's usually good to blame yourself for such matters, for lots of matters, in fact. Question your beliefs and always learn. As programmers, we can sometimes get set in our ways. So to say, you can get a belief, and you think it's the correct one, and maybe somebody shows you. You can be hard to sway from that. So you should always be questioning your beliefs. Even if you come up with something that's good, there might be something better. I oftentimes have thought that I had found the best thing, and I was wary of looking at other places, and that all bit me in the end. Try to stay humble. This goes with the upper one. Programmers can tend to get a little bit arrogant. That doesn't help the questioning your beliefs thing. If you're arrogant, you're less likely to question your beliefs. You're less likely to listen to others. That will only hurt you. Have pride in your code. So if you're writing bad code, that should hurt you. You should feel pain because you should be proud. If you're proud of your code, you're less likely to let yourself write bad code. And that's something you want in an architect. There is use in being able to write code just to get the job done, but not very useful for an architect. An architect should write robust, flexible code, not hacky code. It will come around to bite you if you do. This is a little bit funny one. Be lazy to spawn efficiency. Laziness can be good if you use it right. If you do a task repeatedly and you're a lazy person, you'll be like, how can I make this easier to do? And often, through laziness, we can find ways to make our engines better. And primarily enjoy yourself. If you're enjoying yourself, you'll write good code. You'll write it fast. You'll spend long hours into the night writing code. So finding out how to enjoy yourself is the key. If you're not enjoying yourself, then there's something wrong. Not with you, just with what you're doing. And you need to identify what that is and fix it. Thinking about the big picture. So I always view architecture as kind of like flying over a city, and you're just viewing the entire thing, the entire program. And you have to have an idea of all the code in the engine, how it's going to interact, how all the systems are going to communicate with each other. And you also have to be thinking every time you're writing code, how will this code be used, how will this code affect other code, and how will this code be read. So when I'm writing a function, I ask, how will this function be used by other people? And how can I write the function so that when people go to use it, it'll be easiest to use in the way they want to use it? How will this code affect other code? If I make a change to a function or a change to something, who else is using that? Will it break their pre-existing code? When I'm making a class that maybe plugs into another system, will I break that system? And how will this code be read? So if I go on to my next slide. So when somebody reads your code, what will that code say to them? There's documentation, but you should also be thinking about, is your code self-documenting? If you write a function signature properly, you should be able to tell a lot about what that function signature does just by reading the signature. I'll go more into that later. More to think about, will this code be easy to debug? If you have a class where all the variables are in a pointer that's then in another pointer that's then in another pointer, when you debug that, you're going to have to go into multiple levels to find it. That's going to be nasty. You can solve that a little bit. Visual Studio has some ways to debug, visualize things differently, but that's more work in addition. You can just be thinking about it from the beginning. Will this code be easy to IntelliSense? I'll be going into that more, but you should be using IntelliSense quite a bit. I would recommend Visual Assist to anybody who's using Visual Studio. It costs $50 for students, and that's totally, completely worth it. You're paying a lot more than that for your classes, and you should at least try the trial. And when you do try the trial, you'll get addicted and you'll have to buy it. So, trial's 30 days, Visual Assist, go use it. And are there any other tools I can employ? Yes?
What is Visual Assist?
Visual Assist it improves Visual Studio in many, many, many ways. It'll have things like rename variables, simple things like move implementation to source file. So you can have a function in the header, and you can say move this to the source file, and it'll take it out of the header and properly move it source file. The IntelliSense is just way, way better. Do you have anything to add?
The one thing in it I use the most is go to definition, which doesn't really work that well in Visual Studio, but it's instant in Visual Assist.
Yeah,
So
it is just better. Like it just makes Visual Studio a more usable product. Try it, you'll instantly become addicted. I almost guarantee it. The big slide. So balancing. Architecture is a balancing act. There's no true right answers very often. It's all, you have to make decisions yourself, and this is where it becomes difficult. So we ask questions like, will this interface do everything it needs to? Will there be a chance that this interface will have to be extended? Will it have to do something that I didn't expect that it will do? When that happens, will it be able to be extended to do that? You also have to have that in mind when you're writing code. How might this code change in the future? You might not know for sure, but you should have it in mind that it might. So then you might write features to help it be easily extended. But in doing that, you might increase the complexity. So we have this problem. You could have this super robust thing that can be changed to do anything you want in the world. And it'll be this super complicated class. When your teammates go to read it, they'll be like, this thing's incredibly complicated. It's doing something fairly simple, but it's super complicated. I can't understand it. And you're like, but it could be changed to do anything. But it doesn't matter because they can't understand it in the first place. So it's this balancing act. How hard is it to perform a given task? And so let's say I want to create a game object. And I have to open the XML file, read it in, serialize it, and then pass it to the game object creator. Well, that's very difficult to do something that we're going to have to do a lot. So like, how often is the task performed? Could I make that easier? So I can make that easier by adding a utility function that says create game object from file. You just give it a file name, and then it finds it, opens it, creates the game object. But in doing that, we've added a utility function, which is adding complexity. A little bit of complexity, but if you keep adding a whole bunch of utility functions, you're going to have this big long list of utility functions. You might have too many. Now your teammates, there's so many utility functions, they just can't fit them all in their brain. So you have to make sure that when you do make a task easier, it's something that's being done very often, and you have to keep complexity in mind. Also, talking about utility functions again, where should the utility functions be located? Should they be inside the class? Let's say game object. Should that have utility functions in it for operating on game object, or should I put them outside of game object? A lot of people say that utility functions which are doing something basically that somebody else could do, they're not really adding functionality to the class that couldn't be done by somebody else. So we should have these outside the class because they don't really need access to the private data members. But then the problem with that is then IntelliSense becomes more difficult, because if I say like obj dot and I see all its functions, the utilities aren't in there. So it's a trade-off. You have to think about that. I don't really know the right answer to that. I tend to put utility functions in the class, but a lot of people don't like that. I do it for IntelliSense, personally. And then you have to think, do your utility functions complicate the code? Well, I was talking about with having too many. So I have an example here. It's a game object class with way too many utility functions. It has add component copy, which is taking one by reference. I'll talk more about this. Add component default. So now we have 3 ways to add component. We can kind of imagine what these might do. They could use documentation, but I couldn't fit the documentation into the slide. Add component default. We give it a type. Many of you might not have seen templates, but basically what we can do is pass a type in here, which would be the type of the component. That's what all these templates are doing. So I could say add component default, rigid body, and we could imagine this default one would default construct the component and then add it. Whereas that one up there takes a pointer. So it would take a pointer to rigid body and then add it. Now add component copy takes a const ref. So it's not going to modify the data, but we could imagine it might copy it into a pointer and then add that. So now we have 3 functions, and I don't think the second 2 are particularly useful. We might not use those very often. They're utility functions because they're not really doing more than what you could do. Like if you wanted to copy, you could copy the component yourself and then pass it into the pointer one. Or you could default construct one yourself and pass it into the pointer one. Now if those are being done very, very often, you might want to make utility functions for them. But are they being used that often? We also have add component from file, which takes a path, probably serializes it, adds that component. We also have one from file and memory, where we give it a const char pointer, probably just like the raw data in that component. So now there's 2. Do we need both? That's the decision we have to make. Then we have a whole bunch more utility functions here. Are they really useful? Like assert if not exist. That's a very long name too. So I have another example here where I've paired out all the functions except the necessary ones, or what I felt was necessary. So we have one to get. We have one to check if it has a component release. We probably don't need that. What that would do is basically remove the component from the class but not delete it. That's used in some pointer wrappers. What this does, why we might need it is this is something that couldn't be done if it doesn't exist. So it's not really a utility function. Then we have set, set from file, and memory. Set from file and set from file and memory are utility functions, but when I was designing this class, I felt that they might be necessary. So I kept them in. So it's just deciding which utility functions you think are necessary, which ones you think aren't. Talking a little bit about function signature design, you'll notice my get returns a reference. This means that what happens if it doesn't exist? Well, if I returned a pointer, I could return null. Saying it doesn't exist, it returns null. But since we're returning a reference, returning null is not an option. So what's going to happen? It's probably just going to assert, which is what I would have it do. It would just crash. Pop up a message, this component does not exist. So that's why we have has here. So you would ask, I prefer this behavior because that means if somebody tries to get something that does not exist, it crashes on them. If you do it returning a pointer and they forget to check if the pointer's null, then they end up dereferencing null. And then you get a crash that's outside your error handler. I like my error handler to be catching all errors. So I'd much rather have my error handler get the crash here than a null pointer dereference crash. So if they're not sure if it exists, they ask has first, and then they put that in an if. And if it has it, then they get it. This class isn't perfect. Like, I probably wouldn't actually put release in. But it's better than the last one in my opinion. But it is a pared down one with very few utility functions. So a comment on annotations. So these are things that go before variables, like Hungarian notation. You may have heard of that. Microsoft uses that. I don't like it. I don't think very many people like it. It's a little bit outdated. But I do use these. So before members and classes, I put m underscore. Globals get g underscore, though I don't like to use globals, so we don't see that very often. Constants like pi, other things that just never change, get c underscore. And statics get us underscore. The reason I've seen some people will have something after the name, like I've seen members with health underscore, but I'm doing this for IntelliSense. What I want is when I type m underscore, the IntelliSense realizes I want a member and it shows me only variables that start with m underscore. I find that helps a lot. Or if I'm looking for constants, I type c underscore and I see all the constants in the scope. Or g underscore and I'll see all the globals. I also think it's a little bit useful for readability, especially for the globals if you do have any, or constants. Somebody reading your code, it's very obvious that that variable is a global or a constant. Of course, you could use other ones. I just use these as examples. I find they work rather well. I've seen people do it without the underscores. I like the underscores because they clearly separate that it's an annotation. But it's all a matter of preference. Readability. So when you're writing code, you have to think about what it's going to be like for somebody reading it. I have two functions here. They're the same function. The only difference is that here I put the type def inside the function for this long iterator I'm using. Here I put it's somewhere else. I prefer to have the iterator inside here. So if somebody else comes to this function and they're reading it, if the typedef is not in here, then they're going to have to bounce to somewhere else in the code to check what the iterator means, what it has inside of it. Whereas here, they'll be able to stay at this function, not go anywhere else in the code, and they'll be able to see what the typedef means. Typedefs are very nice a lot, but you also have to realize that they obscure your code a little bit for somebody who's reading it. Because they'll see the typedef, and you know what that typedef means, but unless you give it a very, very explanative name, some other teammate who's reading your code might not know what the typedef refers to, and so they'll have to jump somewhere else to find what it is. So, for example here, if we were just looking at this function, we wouldn't know what first or second were. I'm assuming you know what pair is. Maybe you don't. But down here, we can see either first, either second, and if somebody wanted to know, they could see that those are box pointers. Now, I just thought I would throw in, I would much prefer a for each in this case. For each is a syntax that a lot of higher level languages other than C++ have. C++ is going to be getting one, hopefully, eventually. It's in the C++ 11 standard, but Microsoft has not implemented it yet. I imagine G++ has. Huh?
They have.
Yes, they've done almost everything.
It's in Visual Studio 11.
Oh.
Yes. Wait, what? Yeah, it's amazing.
OK. Well, in that case, I find this to be the most readable out of all of those. So here you can say it's like for each collision pair in M collision pairs. And we can very obviously see what the type is. Very readable. Very easy way to iterate. It's good times. Error handling. So in games, we sometimes wonder, should we try to recover? Most of the time, the answer is no. If you're writing an editor, recovering might be kind of nice, because you often don't want your editors to crash. But that's going to be very difficult to do, to try to recover. Advanced engines may be able to do that, but time scope of a DigiPen project, you're not going to have time to do that. So just let it crash. Try to have formatting on your error strings, so when you output an error, have a nice formatted error message to go along with it. And don't just have like the condition that crashed. Also have a message written by the programmer that explains what happened. And I just put sprintf in here. Like you could have printf-like formatting. If you want to have another type of formatting, you could go and do that too. But printf-like formatting, you should have at least. Don't be afraid of crashing. It's better to crash than allow undefined behavior. If you get a parameter like to one of your functions and it's a little bit weird, some people might say, well, I can try to like tweak it to make it not weird. They might have meant this, and so I'll just kind of change it to what I think they might have meant. Just crash. Like if they press something that's a little bit weird, don't try to think of what they might have meant. Just crash on them. Tell them something went weird. It's better to let them know than to have something that perhaps they weren't expecting happen. For an example, if somebody tries to like get a resource and the extension, the file extension is wrong, and you notice that the file extension, there is another file extension for this that has the same name, don't just like change the file extension they gave you to the one that works. That would be horrible. They made a mistake, crash, let them know. Seen a lot of code where it kind of makes, an example would be normalize. What if they pass a 0 vector to normalize? There are two options you have, two good options, I think. You crash. Normalizing a 0 vector is not good. Or you can return another 0 vector. Unity returns another 0 vector. I prefer to crash. It's kind of a way, because if they pass a 0 vector, they totally didn't intend to do that. So I prefer to crash and let them know. Also print the error to multiple locations. I go to File, the Visual Studio output window, and I pop up a message. It's useful. Like any The file's nice because if you weren't debugging and you accidentally close the message too fast, there's another place you can go. Visual Studio output window's nice. Just why not? So when you're doing architecture, it's good to realize that the biggest part of the engine is the tools. It's also the most difficult part of the engine. We're talking about like level editor, object editor, particle editor, timeline editor, tweaker. These are incredibly difficult, incredibly time-consuming. I know there are teams that have, at DigiPen who have one programmer dedicated to this for the entire year, and they still hate their tools at the end. This is one of the primary reasons why you might consider using a professionally made, pre-made middleware engine. Of course, we don't have that option at DigiPen, but this is a really good reason to go for that. You should, at DigiPen, I would recommend trying to find an external tool that can, rather than writing your own, I would try to find an external one because it's so incredibly difficult to write a tool. Of course, if you can't find an external tool, you might just have to dedicate one of your programmers to making one just for you. But this is really, really, really hard, yet really, really important. And there's no good solution, unfortunately. So you just kind of have to bite the bullet. Messaging. I'm not sure, this is one of the ones where many of the freshmen going into sophomore year probably haven't heard of too much. But it allows you to send messages to one or more objects that may or may not be received. So some examples of this would be a pause message. Like, let's say the game is paused. I could send a pause message. Anybody who's interested in that pause message could grab it. So maybe nobody's interested. Nobody listens to that. Maybe every object in your game's interested. They all grab the pause message, do something about it. Another one would be to send an on-collision message to an object. They may receive it, they may not. What they do depends on the object. This is an incredibly complicated subject, so I can't cover it completely here, but that's a broad overview. What I do want to cover, and this is a little bit more advanced, this is a sort of messaging that I see a lot. I did it on almost all my engines. I don't find that it's very good, though. There's some problems with it. I call it a global message manager. I'm not sure if there's a more proper name. But basically, any class can say, I'm listening. They listen on this global object. They say, when somebody posts a pause message, I want to hear about it. Here's a function to call. Here's my pointer. And it often requires manual registration, unregistration. So somebody will register to listen to this message, and they'll have to manually tell it when they're done listening to the message. So when they die, they'll have to manually remove themselves from this message. The other problem is there's no scoping. So let's say we want to send a message specifically to one game object. With this global message manager, the only thing we can really do is post messages to all game objects, or all people are listening to it. So then when people encounter this problem, they'll make another thing in this global message manager where you can pass a parameter, which is the game object, to send it to. This works, but then let's say you want to send a message specifically to a system. Then you have to add another one to send things specifically to systems. With the object-to-object messaging, you don't have to add these special cases. It just kind of works. So what will happen here is it's all as an object listening to another object. So the pause message might be posted by input or gameplay system. So when an object wants to listen to pause, they listen to pause on the input system or the gameplay system. If they're listening to it on graphics, they won't get it. So all messages are object to object. So when game objects want to listen to an on-collision message, they'll be listening to that specifically from physics, who posts the on-collision messages. This is less error prone because then in the object's destructor, we can automatically remove all messages being sent to or from him. So there's no more manual deregistration. You could have something like this in a global message manager, but it's much more difficult to do. It also adds scoping of messages. So instead of all these messages being global, they're more scoped. It's more robust. I find it works a lot better, especially with script. Once you add a scripting language, this works a lot better. Reflection metadata. This is a topic that could go for 2 or 3 lectures, but I just want people to know what it is. You're saving information that normally would be compiled out. So like classes, their name, their size, their members, what functions they have in them, the names of those functions, the name of those members, the offset of those members, the type of the members, the functions, their signatures, how many arguments they take, their return type. All this you're saving. When C++ is compiled, normally all this, or most of the data is lost, like the names of the classes. All this is compiled out. Reflection saves that. It's useful for serialization, script binding, and creating factories. That's all I'm going to cover for here. We'll probably be doing a lecture on this later, but I just want people to have a broad idea of what it is. Scripting. It helps iteration speed of gameplay code. Unfortunately, binding a scripting language to C++ is time-consuming and very difficult. It requires a very powerful reflection to be robust. You can do it without a powerful reflection, but in my opinion, the script binding will be brittle. It won't be that useful, and it won't be that much better than C++, and so you should probably just use C++ if you're going to do script binding without reflection. Either way, it requires a dedicated, interested team member. If you're doing reflection, this team member will probably be working for about 3 to 4 months. And he better be interested in it because it's going to be a lot of time, a lot of effort. And if he's not having fun, he's probably not going to complete it. And if he does complete it, it's going to be very error prone. It's difficult to do a scripting language in a way that is not error prone. It requires a lot of thought. Simple function binding is an alternative. If you look in Sean's lecture, in his XML, he was able to have a trigger that said, when this trigger goes in, call this function. And that was in XML. So he had a name of the function. So basically, an easy way to do this would just be to have a global hash maps of strings to function pointers. And then so when you see that string in XML, you find the function with that name and you call it. Of course, that function pointer I have there has no arguments, no parameters, which might not be very useful. Unfortunately, passing parameters can be a little bit tricky. What you could do is, because in XML you're going to have the string. So you could parse the string and then pass an array of strings and then have the function parse those. Of course, there's a lot of parsing going on. So that's not ideal either. But you can probably find a way. If we had a reflection, we could make this a lot more powerful. But you can find a way to pass parameters, make it work. And it's a lot easier than full reflection. Useful for an in-game console and data-driven design. So you can have this XML file that has the strings in it. Or you can have an in-game console where you can call functions from that console that have been bound here. Say good enough for Half-Life 2. I mean, I know that the source engine up until recently didn't use a scripting language, so they must have been doing something like this for their in-game console where you can call functions while the game's running. Data structures. So there's a lot of data structures. I wanted to cover a few of the more useful ones I find here. I've ordered them by the likelihood of usefulness in my opinion. Very opinion-based. But this is how often I use most of these data structures. Now, I'm a graphics, physics, and engine dev programmer, so this applies to those areas. Outside of those areas, this might change. Unsorted array. So that's an array, like you think about it, except there's no order to it. You don't care about the order of the things. So when you remove one, normally in an array you think you have to shift everything over to take its place. That's only if you care about the order. If you don't care about the order, you can just take the back one, move it, squash that, and then pop back. So you get a very fast removal. Then I have array. If I do care about order, I'll use the array. Then hash map or set. So this is going to have, it has two variables. It's like a dictionary, so key and value. So you insert it with key and value, and then you can give it the key and get back the value. A hash set doesn't have key value, it just has key. So it's more useful if you put a key in and then you can ask it, does this key exist? I don't use sets very often. I thought I would just include them. I mostly use hash maps. Or you could use a map. I say hash map because it's much faster than many of the tree-based maps. Though not ordered, again. But I very rarely want my maps ordered. Then I have slot map. That's a specialty container where you basically put something in, you get a handle back, and then you can use that handle to fetch the object again. So it serves much of the same purpose as hash map, except it's really, really fast. It's useful for game objects, so you can say, here's a game object pointer, you get a handle back, and then people can use the handle to get the game object pointer again. And the nice thing about the handle is if the game object pointer gets removed and you try to use this handle, it'll say it no longer exists. So you can ask whether the game object is still in the container or not. Then we have intrusively linked lists. These are like normal linked lists, except the next and previous pointer is inside the object. So let's say we have a component pointer. We want to put it in a linked list. We put the next and previous pointer inside the component. And it's a lot faster than if you weren't doing that, like if you're using standard list. And it has many benefits. What I would recommend, if you have a components, there's a lot of times where you just want to list the components. All components of the same type, I might just recommend putting them in a list together. So anybody who wants to get all components of a type, they can just get one component. Now they have next and previous pointers, which is enough to traverse the entire linked list. And you might want to add circularly to this. So it's a circular linked list. So it doesn't like point to null at any point. The back one connects over to the forward one. So from any one, you can traverse the entire list. And then there's trees. They're useful too. I don't use them that often. Useful in UI. Some in graphics for organizing the world. Broad phasing. They can tend to be slow though, which I don't like about them. So I prefer the other ones first, but they do have their uses. Unfortunately, I can't explain how all these work internally. Luckily, you have the internet for that. I just want you to know that these exist. Slot map is something Chris Peters told me about. I'm not sure if it's the proper name for it. So if you can't find it on the internet, come talk to me, Chris Peters, or probably any of the upperclassmen. They'll be able to tell you what it is. Okay, going on to optimization. Don't prematurely optimize. So a lot of people when they're writing code, they're always thinking about, like, is this fast enough? And they're making small premature optimizations before they're really sure whether this code will be the bottleneck. Don't do that. When you're writing code, don't be doing anything that's ridiculously slow. But don't worry about it too much. Don't waste your time worrying about optimization. One thing, the reason I say you want to have it on your mind is because if you have something and you think it might need to be optimized in the future, you need to build your interface so if you do need to optimize it, you can optimize it without changing the interface. You need to be able to optimize it without breaking all pre-existing code. So that is one reason why you should have it on your mind. When you do need to optimize, your game's running slow, use a profiler, like Very Sleepy or PerfHUD I find is useful for graphics. If you look up very sleepy, what it's going to do is you run your program for a while. Very sleepy is analyzing it, and it will give you a percentage time that it's spent in every function. Incredibly useful. So you can say, like, 80% of my time was spent in physics, and then you can keep going down the call stack, seeing which functions in physics took the most time. So when you're running slow, don't guess at what is taking the most time. Programmers tend to think, oh, this code looks slow to me. I'm going to optimize that. Use a profiler, find out what is slow, and then fix that. The other question is, are you GPU bound or CPU bound? So the graphics card and the CPU in a game will be running simultaneously. And one of them will be taking more time. So if the CPU finishes its frame, but the GPU isn't done yet, the CPU will just be waiting for the GPU. And vice versa. If the GPU is done with its frame, but the CPU is not done yet, the GPU will just spin. So if you're GPU bound and you're optimizing your CPU code, it probably won't increase your FPS at all because you're not optimizing the right thing. You're just making the CPU wait longer now for the GPU. So you have to figure out which one it is. You can usually do this because if you're very sleepy, something that's GPU bound, it'll say like a large portion of the frame time is spent in the GPU's present, which is basically the DirectX like end frame call. And then that is the CPU waiting for the GPU to be done. There are a few other ways to check this. Like you can just kind of remove graphics entirely. And if your frame rate doesn't go up at all, then you're CPU bound. If your frame rate goes up a considerable portion, then you're probably GPU bound, though commenting out all of graphics can make the CPU run faster because it takes CPU time as well. So after profiling, how do we optimize this? So can you solve the problem in a different way? Can you use a better data structure? Can I improve my algorithm? Can I use memory more efficiently? These are all questions you ask, but the key is optimize in the easiest way possible. So you ask all these questions, and then which is the easiest to do? There are a lot of times where you can see a way to use this crazy tree that you wrote yourself, and it's going to be super fast, or you can just do something else that's a little bit hacky maybe, but it's going to take you like 2 minutes versus a few days, and it will probably get the job done. Go for the 2 minutes one. Be lazy in optimizing, especially at DigiPen. This is advice mostly for DigiPen because it's easy to get carried away with optimizing, spend way too much time on it. So the key is to optimize it in the quickest way possible. You also have to be optimizing your time in addition, because if I do the easiest way possible, then I have more time to spend optimizing some other code. Or if I spend 3 days optimizing this, then some other code might not get optimized because I didn't have time to optimize it. Blank slide. I'm totally out of time. So questions?